All right, in the previous video, we talked about the rank nullity theorem. We'll use it later this chapter to talk about when two vector space are actually equivalent. But first, we need to talk a bit more about functions. So section 2.2.2, we're going to talk about what a one-to-one and onto linear transformations are. I'm going to start with functions. So definition 2.2.3, a one-to-one function. A function is one-to-one if it maps different elements of x to different elements of y. So let me make this more precise. If I have a one-to-one function, that means that if I take two different elements of x, they're going to be mapped to different elements in y. It's a bit hard to prove a phrase that way because it's hard to start something by saying two elements are different and proving something about it. So we'll turn it around. We'll use what's called the contrapositive. So I'm going to start with an equivalence statement, and that one's going to be easier to work with. So I'm going to start with two images that are the same. So f of x1 is equal to f of x2. So I'm assuming this is false. And I want to prove that then this is false. So I want to prove that if two elements are mapped to the same element in y, then they were the same element in x to start with. All right, equivalent, easier to work with. All right, so let's look at example 2.2.3, determine whether the following functions are one-to-one. So I have a map from R to R. It's actually f of x equals x squared. I wonder if it's one-to-one or not. Does it send different elements of R to different elements of R? It doesn't. So I'm going to look for two different elements in R whose image are actually the same. All right, so I'm going to take x1 to be minus 2. So f of x1 is x1 squared is 4. And I'm going to look at 2. F of x2 is x2 squared is 4. All right, so these images are the same, but these maps are different. I'm sorry, these starting points are different. All right, let's look at what it means for the graph. Let me graph x squared. Oh, it doesn't look good. All right, so I'm going to look at minus 2 and 2. They're going to hit at 4. Right, function is not one-to-one because we have these 2 points that have the same y value. All right, so let's look at a different example. Again, a real function because that's what we're most comfortable with. F of x is equal to 4x cubed. I want to determine whether this is one-to-one. I claim it is. To prove it's one-to-one, I'm going to start with this phrasing here. I'm going to assume that I have this and I will want to prove this. So I'm going to assume that f of x1 equals f of x2, and we want to show that x1 equals x2. All right, so f of x1 equals f of x2. That means 4x1 cubed minus 2 equals 4x2 cubed minus 2. And let's try to cancel things until we get x1 and x2. So I'm going to add 2 here. That's going to give me 4x1 cubed equals 4x2 cubed. Then next step, I'm going to divide by 4. I'm going to get x1 cubed equals x2 cubed. And we have an inverse for the cube. I'm going to cube root it. I'm going to get that the cube root of x1 cubed equals the cube root of x2 cubed. And so I get x1 equals x2, which was my goal. So yes, f is 1 to 1. All right, so a function f from R to R is 1 to 1 if its graph intersects every horizontal line, like we had here, y equals something, so y equal b. We had y equal 4 in our example. So every horizontal graph, actually let me write, I mean I added it on in your notes, but let me add it here. So if and only if its graph intersects every horizontal line once. We don't want more than once. We don't want twice because that would mean two different x's mapping to the same y, but we don't mind 0 or not at all. All right, in the next video, we'll look at what this means for linear transformation. It's actually easier for linear transformation, strangely. You'll see why.